Dear students, in this class now let us discuss about some limit theorems. So, we know that the conditions for convergence of a sequence. So, let x equals xn be a given sequence. The sequence xn converges to x or limit xn equals x. Limit xn equals x means for all epsilon is positive, there exists k1 or k fall in n such that modulus of xn minus x is strictly less than epsilon. Now let us discuss about the boundedness of a sequence. Boundedness means, consider a sequence. Suppose 1 by n is a given sequence. What is actually 1 by n? Sequence 1 by n is, it is 1, 1 by 2, 1 by 3, 1 by 4, etc. Okay. So what is actually the nature of the sequence? Then the elements, that is smaller and smaller, again and finally this goes to 0 when n goes to infinity. So we also know that limit 1 by n equals 0 itself. Now we choose a real number. Suppose 2 is a real number. 2 is a real number. Then all the elements in this sequence should less than the 2. All the elements in this sequence, 1, 1 by 2, 1 by 3, etc. they should less than 2. Or suppose 1 by 1.5. 1.5 is another real number. Then every element in this sequence should less than that 1.5. Means you can find out a particular real number, or we can find out a real number. Suppose it is m is any real number, such that this modulus of this 1 by n less than this less than this m. Okay. Then the sequence 1 by n is said to be a bounded sequence. Here sequence 1 by n is a bounded sequence. Now consider a constant sequence. Suppose consider sequence 1, 1, 1, etc. This is a constant sequence. So this constant sequence means this is a constant sequence. So which converges has in what about the range? So range is a singleton set, so it's a constant sequence. So every element in this sequence, that is 1, that should be strictly less than a particular real number. Suppose you choose a positive real number which is greater than 1, then you can say that every element in this sequence should less than that real number. So the sequence 1, that's a the given sequence of that sequence is nothing but a bounded sequence. But what is consider the sequence n? N means it is a natural number. It is 1, 2, 3, 4, etc. You cannot find a real number such that each of the element or each element in the sequence should less than that real number. You cannot find out such a real number here. You cannot say that there exists a particular m such that the element or the sequence or modulus of n strictly less than m. You cannot find out that m. Why? Because if you add that 1 to the term, if m is a natural number, that is nothing but a real number. Then if you add plus again 1 or 1 some other real terms or 1, here you can find out the number. So you cannot find out such a m. Therefore, the sequence n is not bounded. So generally, a sequence xn is said to be bounded if there exists a real number which is sufficiently large, maybe a real number m such that modulus of xn is less than or equals m. So this is the definition of the boundedness of a sequence. For all m followed, sequence xn is said to be bounded sequence if there exists a real number m fallen near R such that modulus of xn less than or equals m. Means you can find out a real number m which is sufficiently large enough such that modulus of xn less than or equals that m. Okay. Then now let us consider the properties of this bounded sequence. Is bounded sequence convergent or convergent sequence is bounded? What about a convergent sequence? Can you say that the convergent sequence is bounded? Convergent sequence. What is the relation between the convergent and bounded? is convergent sequence is a bounded sequence. Can you say that this one? Convergent sequence is a bounded sequence. So far, let the sequence xn be a convergent sequence. Sequence xn converges to x. Sequence xn converges to x means for all epsilon is positive, there exists a real number k, so there exists a natural number k, such that modulus of xn minus x strictly less than this epsilon. For all n greater than or equals k. What is epsilon? Epsilon is a real positive real number. So put down epsilon equals some 1. Epsilon is 1. So means this happens modulus of xn minus x strictly less than 1 for all n greater than or equals k, where k is a natural number. But we know that modulus of mod a minus mod b less than or equals modulus of a minus b. Modulus mod a minus mod b less than or equals modulus of a minus b. So for modulus of mod xn minus mod x, this less than or equals modulus of xn minus x with the light of this argument. But mod xn minus x strictly less than 1. So that means modulus of xn strictly less than 1 plus mod x from here. Okay, mod xn less than 1 plus mod x. Mod xn less than 1 plus mod x. Then you can put a real number. Suppose m equals maximum of m equals max x here. This is true for all n greater than or equals k under this condition. Okay, put m equals maximum of mod x1, mod x2, etc. mod x k minus 1. This is true for every n greater than or equals k and 1 plus mod x. Choose m is nothing but this one. Since x1, x2, etc. that's a sequence of real numbers. So modulus that's again a sequence of positive reals. So m equals maximum mod x1, x2, etc. mod xk minus 1 and 1 plus mod x. Why the choice is this way? Because of we choose this n greater than or equals k. So the choice of this one is depends upon this n. Okay. So clearly this is 1 plus mod x. M equals maximum of mod x1, mod x2, etc. mod xk minus 1 and 1 plus mod x. From here there's mod xn less than or equals m for all n greater than or equals k. That means secant xn is a bounded sequence. Secant xn is a bounded sequence. Actually, what is secant xn? That's a convergent sequence. So from here we can conclude that the convergent sequence is always bounded. Convergent sequence is bounded. Convergence should imply the boundedness property. Convergent sequence is a bounded sequence. What about its reverse inclusion? What about the reverse inclusion? Is a bounded sequence convergent? Here we prove convergent sequence is bounded. What about the reverse? Do you say that a bounded sequence, or do you prove that a bounded sequence is a convergent sequence? So consider sequence. Consider that y equals sequence yn equals 0, 2, 0, 2, 0, 2, etc. Here the elements repeats 0, 2, 0, 2, 0, 2, etc. That does not, as clearly modulus of yn, mod yn less than or equals 2, or if you choose any other real, mod yn less than or equals 2, clearly the sequence yn is bounded. Secant yn is bounded. But what about the convergence of that one? Clearly we know that the sequence does not converge this. Why? Is it converges? No, the sequence yn does not converge this here. Why? Suppose here the elements are 0, 2, 0, 2, etc. So there are two possibilities. Either this yn converges to 0 or this yn converges to 2. Okay. So that never happens. This is sequence does not, the sequence yn does not converge. If it suppose it converges to 0, what happens? If it converges to 0 means modulus of yn minus 0 less than some epsilon. Okay, for all n greater than or equals k. That means mod yn strictly less than epsilon. Put epsilon is 1. So mod yn is 1. Here 2. 2 less than 1. That's a contradiction. So it does not converge to 0. So thus the sequence is not a convergent sequence. So but sequence is a bounded sequence. Sequence is bounded but it not converges. Okay. So a convergent sequence is always bounded, but a bounded sequence need not be converges. Suppose it converges to 2, what happens? Mod yn minus 2 less than epsilon. Okay. Then put epsilon is a smallest quantity. Then there should be again a. So the convergent sequence is a bounded sequence, but the bounded sequence need not be converges. The reverse inclusion it does not hold. Agree? Now, let us secant xn is a convergent sequence. X equals xn. Let us secant xn is a convergent sequence of real numbers. Secant xn is a convergent sequence of real numbers with xn greater than or equals 0. With xn greater than or equals 0. Then limit xn also greater than or equals 0. If xn be a sequence of real numbers and if xn greater than or equals 0, then limit xn also greater than or equals 0. How to prove? So the proof is done by using contradiction method. Assume as it is given, suppose sequence xn converges to x. Now to prove, let x equals limit xn. Let x equals limit xn means xn converges to x. Now to show this limit xn greater than or equals 0 means that we want to show this x greater than or equals 0. Assume x less than 0. X less than 0. We have to show that, or we want to show that this x is greater than or equals 0. That's our requirement, that's our goal. But here we just assume this x is negative. X negative means what is minus x? Minus x is positive. Okay. Then let epsilon is positive. Epsilon greater than 0. Then mod xn or x equals limit xn or xn converges to x. Xn converges to x means for all epsilon is positive, there exists k following n such that modulus of xn minus x strictly less than epsilon for all n greater than or equals k. That means from here it is minus epsilon less than xn minus x less than epsilon. Okay. That means x minus epsilon less than xn less than x plus epsilon. Okay. For all n greater than or equals k. The condition holds. Enough. But what is epsilon? Epsilon is positive. What is minus x? Minus x is positive. So put minus epsilon equals minus x. Put epsilon equals minus x. So this relation becomes, when epsilon is minus x, it is x minus minus x less than xn less than x plus minus x for all n greater than or equals k. That means 0 less than xn less than 2x. So 0 less than xn, come to the first inequality. 0 less than xn, that's a contradiction because by the choice of xn it is non-negative free. So that's a 0 less than xn, that's a contradiction to the choice of xn. This contradiction is due to our wrong assumption, therefore this x should be positive. X positive means, or x does not, sorry, x not less than 0. X not less than 0 means x greater than or equal 0. What is this x? X is limit xn. Why? Because this x is the convergent point of the sequence xn. So limit xn greater than or equal 0. That's our A. Okay.